what's going on? Sorry I couldn't be there with everyone today, but we are going to pick up on page 3 of your note packet, taking a look at Intro to Congruency Proofs. So just going to walk through today. We'll review this again tomorrow, and we'll keep doing a little bit more. I'll also have this sheet of paper for you guys tomorrow. We're going to, not this one, we're going to reference it today though. If you remember our triangle congruency notes from last unit, feel free to keep this out as we work through today. We're going to talk about how to do a proof though, and then also our laws that we're going to get into in a minute here. So today we're working on page 3, and then the first thing we're going to talk about, we've mentioned before, we can determine whether two figures are congruent by comparing their corresponding parts. So if we know that figure ABCD is congruent to figure EFGH, that means that, right, angle A is the same as E, B is the same as F, C is the same as G, D is the same as H. So the order of the letters does matter, and then it tells us what sides and angles are congruent. So the first two letters here, A, B, are equal to the first two letters there, the second two letters, and so on and so forth. So make sure when you name the polygons that are congruent, whether it's triangles or rectangles or whatever, we list their corresponding vertices in the same order. Okay. On to the special note sheet for today, which you guys will be getting on Monday. So there are 5 different ways to show that triangles are congruent. So if you give me 2 triangles, I can prove they're congruent by checking to see if all 3 sides in one triangle are congruent to the 3 corresponding sides in the other triangle. This is called the side-side-side congruency theorem. The second one is what's called the side-angle-side congruency theorem. And it's important that you have the 2 sides, okay, and the angle that's in between them, right? The angle that's in between them. This is called the included angle, okay? So 2 sides and the included angle. All right. If the angle is not included, if it's one of the other 2, that's a different theorem we're going to talk about. Now the next one is angle, side, angle, so ASA. Okay, we have to have 2 angles, so 2 angles, and then what's called the included side. Okay, so the side that's connected right in between them, this side that's connected in between them is going to be congruent. So 2 angles, all right, and the side in between. Remember, side angle side was 2 sides, okay, different slashes to show they're congruent but not to each other, and then the angle in between called the included angle. So this is called the included side, ASA. All right, now instead of making this side congruent, okay, if we were to say, let's ignore this side for right now, all right, and we were to make this side congruent over here, this is this theorem, which is called angle, angle, side. Angle, angle, and then the side either on the bottom or on the right, which is not included, okay? So if it's in between the 2 angles, it's angle, side, angle. If it's one of these other 2 sides, okay, it's angle, angle, side, all right? The last one is only for right triangles, and it's called hypotenuse leg, okay? So if we have the hypotenuses of 2 triangles congruent, okay, we've got to know it's a right triangle, and one of the corresponding legs, okay, then we would know that these 2 triangles are congruent, and it basically comes from the Pythagorean theorem. We would be able to use the Pythagorean theorem to show that these 2 sides are equal, and then we would have side, side, side. So we use HL if it's a right triangle with the hypotenuse. Now remember, the hypotenuse is always across from the right angle, okay? So when you make a right triangle, the hypotenuse is always across from it. The right angle kind of makes an arrow, okay, that points at it, all right? Okay, theorems that don't work. Angle, angle, angle. So remember, we talked about the fact that dilations, okay, preserve angle measure, but not side length, right? So I can take one triangle, all right, I can make it bigger. I can make this triangle bigger. So if let's grab this for a second. I'm going to duplicate it. Copy, paste. All right, and we're going to stretch it out, okay? And you can see that these angles are still going to be the same length. These angles are still going to be congruent, okay? It's just that, right, the side lengths are what's not congruent, okay? So keep that in mind as we go along here, all right? The angles are equal, but not the sides. So AAA, or angle, is not for congruency. It's for what's called similarity. Same size, different shape. The other one that doesn't work, we'd like to call the donkey theorem, okay? The donkey theorem, like right? The angle, side, side. We don't want to write bad words, so we say side, side, angle theorem, okay? That's why we call it the donkey theorem. So if we have, okay, two sides congruent, all right, and one of the other angles. So if I knew that this angle was this many degrees, okay, here's what can happen. I don't know this side length, so it's just going to be a dotted line for right now. I don't know what this angle is, okay? So in this scenario, we could theoretically swing this side around, all right? And depending on the length of these sides and the angle measure, this could create two triangles. It could create this triangle right here, okay? Or it might create this triangle right here because this side can hit in two different spots, okay? So for purposes of what we're going through, so for our purposes, just remember, we're not going to use the donkey theorem, right? Bad words. Thanks, Kate. Or the angle AA theorem, okay? Say hi to everybody. That's Kate. All right. No donkeys, right? We don't use donkeys here, okay? So no donkey theorem, okay? And no angle theorem. So it's HL, AAS, ASA, SAS, and SSS, okay? So if we take a look at the first page here, which theorem are we going to use for each triangle? So number one, look what we have. Okay, we have two sides equal in both triangles, right? And we have the angle that's directly in between them congruent. So this is side, angle, side. So if you were walking around the triangle, right, you would see SAS. This is the SAS theorem. Okay, what about number two? All right, hopefully you thought to yourself that we have angle, side, and then an angle, side, angle. This is ASA. Okay, what about number three? Now, three is a little tricky. I don't have any sides equal. What I do have is parallel lines. And if we remember, we can use our Z here to get angle A congruent to angle B. And we also have another Z running the opposite direction. So I can get angle W congruent to angle X. And I also have vertical angles in the middle. So I would be able to get angle, 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 but we know that doesn't work. Okay? So if it says not congruent, you can say not enough information. All right? And we know that we can't use angle, angle. Okay, number four also looks like we don't have enough information, but it's tricky because this triangle, ACB, and the triangle on the bottom, right, ADB, actually share this side. They have this side in common, right? So AB in the blue triangle is equal to AB in the red triangle. So this side is congruent. This is called the reflexive property, all right? Any two things are equal to itself. Anything is equal to itself, reflexive property. We're going to put an X on the side when we use it. And now we know that we have angle, side, angle. And if it's tough to see, I would redraw one of your triangles so that you can see what's going on, right? We have angle, the side, and then the angle. So this is ASA. Okay, what about number five? And really, if you want to, let's pretend that this isn't the one that's marked congruent here. Okay, hold on a second. Let's pretend that this isn't the one that's marked congruent. Oh, geez. All right, let's pretend it's this one down here. It looks a little more realistic. So is there enough information to show that these are congruent? Okay, well, the only thing we'd be able to say is the same is SQ again. SQ is the same in both triangles, right? It's in the top triangle, okay? And it's the same as the side in the bottom triangle. So it's, once again, that's reflexive. And now, what do we have? Well, if we look at this, just this triangle PQS here, okay, I have side, side, and an angle, or angle, side, side, right? Remember, we're not allowed to write these bad words here. So this is the donkey theorem, okay? So this is also not enough information. Okay, last one here. All right, we know that the two sides are equal. The angle, remember we just talked about before, this side right here is shared in between the two triangles. We can put the X on it. And now look at what we have in the triangle on the right. We have a side, angle, side. So even if it's the right triangle, right, we don't have the hypotenuses and the triangles congruent. So this is an HL, it's side, angle, side. Okay, that's it. That's all we're doing for the first part here. Okay, so here's another example. And once again, when you read the example, make sure you mark your diagram. So in the triangles below, AB is congruent to DE. Angle A is congruent to angle D. And angle B is congruent to angle E. Two arcs there. What do you think? And hopefully you picked ASA. All right. All right, let's take a look at number 8. Okay, so this is once again from our givens. So remember, keywords. AE bisects BD at C. So we know that BD is getting cut in half. So if BD is cut in half, we know that BC is congruent to CD. Okay, it just says that these lines are drawn. And we also know that angle ABC, so this angle right here, is congruent to angle EDC. We don't know it's 90, but we know that that's going on. Which statement is needed to prove the triangle is congruent by angle, side, angle? Angle, side, angles. Think about it. If these angles are right angles, that could be angle, side, angle. If BD bisects AE, so if we cut AE in half and we get these two equal, is that angle, side, angle? If BCA, right, is congruent to DCE, is that going to give us angle, side, angle? Or is it going to be DEC, right, and BAC? Which one's going to give us angle, side, angle? And hopefully you picked the vertical angles here. Choice 3, angle, side, angle. Okay, moving into our congruency theorem proofs. All right, so our job is going to be to show that these two triangles are congruent. So let's take a second and let's go back to our note sheet here. And let's look at how to do a proof. Now we already know how to do a proof from before, so we know we're going to fill in the givens, right? And then in the statement column and in the reason column, we're going to put given, okay? We are then immediately going to label our diagram. So mark off what you know is congruent, okay? And then we're going to look for keywords in the given, okay? We're also going to look for, right, our parallel lines to make the Z, if we have any, okay? And we're going to look for any reflexive property steps here. Is there anything, any sides that are shared between the two triangles? Okay, so as we go, we're going to continue to label our diagram, and we're going to use the picture to determine which of our theorems to use congruent. We have to get one of these 5 to happen. Our last statement is going to be whatever the proof statement is. So always remember, the last statement is always going to be the proof, and the reason is going to be one of these statements: side, 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 congruent to side, side, side. We're going to use the theorem for the last reason. Okay? So what if you get stuck? Remember to trace or draw the triangle separately so you can help you get an idea of what theorem to use. So if you redraw the triangle, right, and you can mark down this for yourself, right, then we might be able to see, oh, that's angle, side, angle. It might be easier to see when you draw it separately. Okay, we talked about looking for keywords. Midpoint, right? The middle of the segment cuts it in half. Right triangle, we have a 90-degree angle. Perpendicular, two lines that cross and form 90-degree angles. Not a perpendicular bisector, that's different. Okay, bisect, line that cuts through another line and cuts it in half. Remember, isosceles is a triangle that has either two sides, right? And if the sides are equal, you know the angles are equal. And if you know the angles are equal, you know the sides are equal. Okay, look for those keywords. All right, let's try it. Let's take a look at the first one. Okay, go ahead and fill in your statement and reason. Okay, pause until you get it done. All right, now remember, we have to get one of the 5 theorems to happen. Side, 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 angle, side, angle, angle, side, or HL. That's what we're looking for. So we're going to look for our picture and use this to help us out to determine this. As soon as we write this down, we notice automatically that I already have 2 sides congruent. So let's mark them down for ourselves. AC is congruent to BC. Okay. I also have a key word, right? The X is the midpoint. So we're going to make a new statement from this, right? If this is in the middle, right, what can we say because of this word midpoint? Okay, so if X is the midpoint, we're going to create a new statement. If X is the midpoint and it's in the middle, then this side AX is going to be equal to this side BX. So we can write down AX is congruent to BX. The reason is just like we used before when we were doing the parallel line proofs, right? The midpoint, okay, cuts the segment into 2 equal parts. Okay, now we've used up all our keywords. Okay, so now we have to look at our diagram. Remember we talked about, I'm looking for this triangle, ACX, okay, and this triangle, right, BCX, and I want to know why are they equal. Remember, I just traced over the same line twice. So this is our reflexive line. It's being shared. So we're going to write down for ourselves, we have to say that it's the same. So we're going to write down XC is congruent to XC. Seems a little ridiculous, but we need to make sure we say that it's congruent. And anytime you write the same thing equals itself, that's always the reflexive property. Okay. And now look at your triangles, right? Do we have enough to say that these 2 triangles are equal? We have the side on the bottom, and our reflexive side. So we have enough. So we're going to write our proof statement. Triangle ACX is congruent to triangle BCX. Which theorem did we use? Right? We use side, side, side. I always write side, side, side congruent to side, 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 just so you know that the 3 sides over in this triangle are congruent to the corresponding sides in the other triangle. All right, let's try number 2. Okay, so go ahead and fill in your statements and reasons. All right, now remember, we already know that 2 things are congruent, and we have a keyword of bisects, and we're bisecting the angle. So we're going to mark down angle 3, congruent to angle 4. Now we don't know that these are right angles, so don't put a right angle mark. It could be 89, it could be 90.5, right? We don't know what they are. All right. Now from that keyword, right, what does bisects mean again? Right? Bisects cut in half. What are we cutting in half? We're cutting in half this angle, SRT. So if we cut an angle in half, right? If we cut an angle in half, I better get 2 angles back. If you cut an apple, you don't get 2 oranges, okay? So I get these 2 angles congruent. So now we know that from this angle, we can say that angle 1 is congruent to angle 2. Keyword is bisect, so let's use that in our given. So if you bisect, we can actually say angle, bisect the angle, but we can also say the angle bisector, okay, cuts angle into 2 equal parts. And if you wrote down bisector, just bisector of an angle cuts it into 2 equal parts, so you can write that. Okay, let's mark these congruent. And we need 2 arcs now to indicate that these are congruent. And is anything else the same? We've used our keyword, right? We've marked this down. So now we have to look at our picture. Anything you notice is the same? All right, hopefully you picked up on that shared side again in the middle. Good. So let's fill that in. Seems a little ridiculous, but we have to say RZ is congruent to RZ. Attribute to Mr. Ziol there. All right, reflexive property. And now do we have enough in our triangles? So let's look at the triangles, right? We have the angle up top, we have the angle down here at the base, and we have this side marked. So we have angle, side, angle. All right, do we have enough? So we do our proof statement. RZS is congruent to triangle RZT. And then we're going to put down angle, side, angle. Congruent to angle, side, angle. All right, nice. Okay, let's head down to number 3. Let's go ahead and fill this one in. Okay, so same thing now. So we're going to go ahead and mark down what we know. So we already know that angle 3 is congruent to 4. So let's go ahead and mark that down. So angle 3 is congruent to angle 4. Okay. We also know that AB is congruent to CD. So we can go mark that down. AB is congruent to CD. And we also know that PB is congruent to PC. So PB, which is this side, is congruent to PC. Okay. Now there's a whole bunch of triangles going on here. There's like 5 different triangles. The big one, these 3, and then there's this one and that one. So what triangles are we actually talking about? So ABP, so that's this triangle. We're trying to show that it's congruent to this triangle over here, right? DCP. Okay. So in this triangle, right, what do we know is congruent already? Well, we have this side and this side. So either we can try to get these 2 sides equal right on the edge, or we're going to need to get this angle, because if we get one of these 2 angles, we're going to have the donkey theorem, right? Angle, side, side. So this is the key thing. If we know that these 2 angles inside are congruent, we're going to want to use them to get these 2 angles on the outside congruent. We've done this before, right? What do we notice about these 2 angles and these 2 angles separately, right? Right, they make a straight line, right? So that means, okay, that we can say that angle 1 plus angle 3 is going to equal, good, 180. And angle 2 plus angle 4 is going to equal 180. We can put them in the same step because it's the same reason, right? And we can either say linear pair of angles, we can say supplementary angles, okay? Angles on a straight line, they all add to 180. So one of those 3 reasons would be appropriate here. Okay, what do we do when we have 2 things that are equal to the same amount? We set them equal. So angle 1 plus angle 3, right, is equal to angle 2 plus angle 4. Okay, and that's substitution. You can also use transitive here. That would be okay. All right, and then remember, we know from the given that 3 and 4 are equal. So if we were to subtract angle 3 from both sides, right, from both sides, okay, we know that this is going to reduce out. Now, we're not actually going to show the work, but that's really what's going on here. So we know these are going to go away, and we're going to get angle 1 is congruent or equal to angle 2. Okay, and this is the subtraction property of equality. We're going to be using this a lot in the next couple days here. Okay, so get these 2 angles equal to the same amount, sums, set them equal, and then subtract away what's the same. Now that we know that angle 1 is congruent to angle 2, right, now we can see that we have, right, angle, side, angle, and now we have enough. So step 5 is going to be our proof statement, angle triangle A, BP is congruent to triangle DCP. Okay, and once again, that's angle, side, angle. To angle, side, angle. All right. Okay. 4 and 5 here. Let's see if you can try these ones on your own, and we'll go through them in class together on Monday. So give these ones a shot, okay? And then we'll go through them together on Monday. So remember, label what's congruent, okay? So these two angles are congruent. The angles at B and D, okay? We almost have enough. There's one more thing you need to make those two triangles congruent. And for number 5, right, if perpendicular, ooh, remember that means, right? That means you got 90-degree angles, so make a statement from that. Okay, HMA and HTA. All right, we're going to have these 90-degree angles congruent, and then what else is the same? And see if you can push these two together. Okay, try these ones on your own. All right, we'll go over these tomorrow, and then day 4 we'll do this isosceles triangle if we go over these two proofs. All right, guys, have a great weekend. We'll see you on Monday.